Hello friends, today we are going to look at congruency and similarity. This is part 18 of 25 on Euclidean geometry, okay? Before we can learn about congruency and similarity, we have to know the concept of ratio and proportionality, okay? So, ratio and proportionality. So, you have to know about ratio and proportionality. You are going to use this in order to understand congruency and similarity. So, a ratio describes the relationship between two quantities which have the same units. We are going to see that. So, we can use ratios to compare lengths, areas, volumes, age, and many other things. Okay, so a ratio is a comparison between two quantities of the same kind and has no units. We are going to see that. So let's say, for example, if you have AB, okay, the length AB equal to 5 centimeters and CD equal to 10 centimeters. Now we can express the ratio between AB and CD like this. AB and CD. So AB is 5 centimeters. You are going to write 5, and CD is 10 centimeters. You are going to write 10. So a ratio has got no units. Okay, you have 5 is to 10. You can carry on and simplify. 5 by 5, 1. 10 by 5, 2. So the ratio between AB and CD is 1 is to 2. You can also express the ratio as a fraction, okay? AB over CD. This is equal to AB is 5 over CD. CD is 10. You carry on, you divide by 5, 1 over, you divide by 5, 2. So you can express the ratio like this or as a fraction. Now, proportionality. Okay? Proportionality is the equation that expresses the relationship between constant ratio. Okay? So, if two or more ratios are equal to each other, then we say that the ratio are in the same proportion. So, for example, you have AB over CD, which is equal to 5 over 10. Okay? AB over CD, which is equal to 5 over 10. This is equal to 1 over 2. So, if you have this ratio and another ratio between KL and MN, which is equal to 4 over 8. If you simplify, you are going to have 1 over 2. Can you see? The two ratios are equal. Okay? 1 over 2 and 1 over 2. Because the two ratios are equal, we can go ahead and write the proportionality equation. So, the proportionality equation is AB over CD is equal to KL over MN, because these ratios are equal. Okay? 1 over 2 and 1 over 2. Now that you know about ratio and proportionality, we are going to use that concept to understand congruency and similarity. You can use congruency and similarity in many different shapes, but in this video we are going to use congruency and similarity in triangles. Okay, so two triangles are described as congruent if the two triangles are identical. So the lengths of three sides and the sizes of triangles must be equal between the two triangles for them to be congruent. So the lengths of the three sides in one triangle must be equal to the lengths of the three sides in another triangle, and the sizes of the triangles in one triangle must be equal the sizes of the triangles in another triangle for you to conclude that the two triangles are congruent. Now, the symbol we are going to use for congruency is three horizontal lines. So let's see the first example. Okay, A, you have triangle A, B, C and triangle P, Q, R. You can see side AB is equal to side PQ. Okay, side AB is equal to side PQ. Okay, you can see, and side BC is equal to side QR. Okay, BC is equal to QR. Okay, and AC, okay, AC is equal to PR. Okay, AC is equal to PR, and you can see the angle A is equal to the angle P. Okay, angle A is equal to angle P, and angle C is equal to angle R. Okay, angle C is equal to angle R, and angle B is equal to angle Q. Okay, so you have the lengths of three sides in one triangle equal to the lengths of three sides in another triangle, and you have the sizes of triangles in one triangle equal to the sizes of triangles in another triangle. Okay, so because of this, you can conclude triangle ABC is congruent, okay, congruent to triangle PQR. So always make sure whenever you write down that this triangle is congruent to this triangle, you have to respect the order. You can see the angle at A in the triangle ABC is equal to the angle at P in the triangle PQR. Okay, and the angle at B in the triangle ABC is equal to the angle at Q in the triangle PQR, and the angle at C in the triangle ABC is equal to the angle at R in the triangle PQR. You have to respect the order. Okay, this is why I have different colors so that you can see. Okay, angle A is equal to angle P. Okay, angle B is equal to angle Q, and angle C is equal to angle R. always respect the order. You are going to see why you have to respect the order. If you don't respect the order, everything that you are going to write after this will be wrong. So, from this, you can go ahead and write the proportionality equation. Okay, let me show you. So, let me get, a black pen. So, from this, you can use the first and second letter. Okay, let me reduce the thickness of my pen. So, use first and second letter. Okay, so AB over, in this triangle, you are going to use the first and second letter as well. Okay, so you have P and Q. Okay, P and Q. So AB over PQ. Okay, now you are going to use first and third letter in this triangle over first and third letter again, okay, in another triangle. So you have, this is equal to AC over PR. Okay, you carry on. This is equal to, you are now going to use, let me use a different color. You are now going to use second and third letter in this triangle, and second and third letter in this triangle. Okay, so you have BC over QR. Okay, can you see? This is why you have to respect the order. Okay, always make sure the angle at the first letter in this triangle is equal to the angle at the first letter in this triangle, and the angle at the second letter in this triangle is equal to the angle at the second letter in this triangle, and the angle at the third letter in this triangle is equal to the angle at the third letter in this triangle. So now, this is equal to 1 because AB is equal to PQ. Let's say you have 5 over 5, or 3 over 3, or 10 over 10. This is 1. You can see AC is equal to PR. AC is equal to PR. Okay, so AC is equal to PR. AC over PR, this is 1. Again, BC is equal to QR. So BC over QR, this is equal to 1. So in the case of congruency, the proportionality is equal to 1. So the two triangles are congruent. Okay, so the above two triangles in A, okay, in A are congruent. Now let's see about similarity. So two triangles are described as similar if they have the same shape but might vary in size. Okay, we are going to see about this. Okay, so when the sizes of three angles between two triangles are equal, it is a sufficient proof for similar triangles. In the case of congruency, you need to check the lengths of the sides and the sizes of the angles. In the case of similarity, you need to check only the angles. So, similar triangles might have equal lengths of sides, or the lengths of sides are always in proportion. So, when two shapes are similar, their corresponding sides are in proportion. Okay? All triangles that are congruent are similar as well, but not all similar triangles are congruent. So, in example A, you have similar triangles as well. The symbol used for similarity is 3 vertical lines. You can see in the word similarity, you have 3 eyes. Okay? Similarity, you have 3 eyes. Okay? 3 vertical lines. So you can use this to remember the symbol for similarity. So let's see an example. Okay? Example B. You can have a triangle DEF and triangle GHJ. So in triangle DEF, the side DE is equal to the side GH. In triangle GHJ, and side EF is equal to the side HJ, and side DF is equal to the side GJ, and angle D is equal to angle G, angle E is equal to angle H, and angle F is equal to angle J. So this is enough for you to conclude that the two triangles are similar. Okay? You only need to check the sizes of the 3 angles in one triangle as compared to another triangle. So you can say the above 2 triangles in B are similar by checking the sizes of the angles. The 2 triangles are similar. Now, example C. You have this triangle and this triangle. The 3 angles in this triangle are equal to the 3 angles in another triangle. So, you can see angle S is equal to angle Y, and angle T is equal to angle Z, and angle R is equal to angle X. You can say, because of this, therefore triangle RST is similar, similar to triangle XYZ. Always make sure you write this in the correct order. So the 2 triangles are similar. So you can say the above 2 triangles in C are similar. So in B, these 2 triangles are similar and they are also congruent, but not in C. The triangles in C are not congruent because of the lengths of sides. They are similar but not congruent. So for congruency, you need these 2 conditions: lengths of 3 sides and sizes of 3 angles. For similarity, you need 1 condition: sizes of 3 angles. You can see the difference. You understand in this example, the proportionality of the sides is equal to 1, as in A. You can see DE is equal to GH. Okay, same size over same size. This is 1. EF is equal to HJ. Same size over same size. This is equal to 1. DF is equal to GJ. Same size over same size. This is equal to 1. Now, for this, you understand the proportionality of sides is not equal to 1. Okay? You are going to see that. You can now write the proportionality equation. So, you take first and second. Okay, let me use a black color. First and second in this triangle over first and second in another triangle. Okay, so you have the proportionality of sides in C. Okay, in C is RS over XY. This is equal to, now you are going to take first and third in this triangle over first and third in another triangle. Okay, so you have RT over XZ. This is equal to, now you are going to take second and third in this triangle and second and third in another triangle. Okay, so you have ST over YZ. Okay, first and second over first and second, first and third over first and third, second and third over second and third. So you understand, in this situation, the proportionality equation is not equal to 1 because you have RS is not equal to XY and ST is not equal to YZ. RT is not equal to XZ. The lengths of sides are always in proportion when you have this condition. For this situation, the proportionality equation is not equal to 1. Okay? This can also be written like this. Instead of RS over XY, you can have XY over RS equal to XZ over RT equal to YZ over ST. This is not equal to 1 again. Another thing that you have to pay attention is, can you see RS, RT, ST? What you have in the numerator is from one triangle. Okay, RS, RS, RT, RT, ST, ST. What you have in the denominator is from another triangle. Can you see XY, XY, XZ, XZ, YZ, YZ. Okay, we are going to use this in many examples. Okay, so let's move on. We can tell whether two triangles are congruent without testing all the sides and all the angles of the two triangles. Okay, so there are 5 properties or 5 rules to prove triangle congruency. Okay, there are 5 properties or 5 rules to prove that two triangles are congruent. We are going to see those 5 properties. So we are going to have our table. Okay, so the first property is SSS, which is side congruency property. So if you are comparing two triangles, if you can prove that the 3 sides in one triangle, the 3 sides in one triangle are equal to the 3 sides in another triangle, this is sufficient to conclude that the two triangles are congruent. So we are going to explain as when the 3 sides of a triangle are equal to the other 3 sides of another triangle. Okay, now property number 2, sides angle sides congruence property. So you can have something like this. Okay, this side is equal to this side, this angle is equal to this angle, and this side is equal to this side. You can see you have an included angle. An included angle means an angle between two sides. Okay, this angle is between AB and BC. This angle is between PQ and QR. So explanation: when two sides and the included angle of a triangle are equal to the two sides and the included angle of another triangle, as in this case. Okay, the third property, which is angle sides angle. Okay, ASA, angle sides angle congruence property. So if you can prove that you have two angles and an included side, okay, a side between two angles in one triangle are equal to the two angles and the included side in another triangle, this is sufficient to conclude that the two triangles are congruent. Okay, so when the two angles and the included sides of a triangle are equal to the two angles and the included sides of another triangle, this is sufficient to conclude that the two triangles are congruent. The fourth property, which is angle sides. Okay, angle sides congruence property, or this can be written as side angle. Okay, side angle side angle congruence property. Okay, so this is the same. So you have something like this: angle sides. Okay, angle sides, or side angle. Okay, side angle. So when two angles and none included sides, meaning the side is not in between two angles. Okay, when two angles and the none included sides of a triangle are equal to the two angles and the non-included sides of another triangle, as in this case, you can conclude that the two triangles are congruent. Now, the fifth property, number 5, you have RHS. Okay, right angle, hypotenuse, and side congruence property. Okay, so you have something like this. Okay, so when the hypotenuse and one side of a right triangle are equal to the hypotenuse and one side of another right triangle, you can conclude that the two triangles are congruent. So, in conclusion, triangle ABC is congruent to triangle PQR. It means the three sides and the three angles of triangle ABC, okay, ABC are equal to the three sides and three angles of triangle PQR for all five properties. For all five properties, you have this, okay? So, remember, in the case of congruency, the proportionality of sides is equal to 1, okay? Remember from the previous slide. Now, you can have a situation where there is no congruence of triangles, okay? So, you have side-side angle. So, side-side angle is not sufficient to conclude that two triangles are congruent because it may make two different triangles, okay? In the previous slide, we learned these 5 properties for congruence of triangles, okay? Side, 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 an included angle, an included side, angle, angle, side, or side, angle, angle, and right angle, hypotenuse, side. Now, the properties for similarity. There are 2 properties or 2 rules to prove triangle similarity. Okay, we are going to have a table. Okay, the first one is side, 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 as in the case of congruency. You can have something like this. If the 3 sides in one triangle are equal to the 3 sides in another triangle, this is sufficient to conclude that the 2 triangles are similar. Okay, explanation. When the 3 sides of a triangle are equal to the other 3 sides of another triangle, you can conclude that the 2 triangles are similar. The second property is angle, angle, angle. Okay, so you have something like this. Okay, when the 3 angles in one triangle are equal to the other 3 angles of another triangle, you can conclude that the 2 triangles are similar. Okay, so conclusion, triangle DEF, okay, DEF is similar to triangle GHJ, okay, GHJ, okay, and from this you know the 3 angles in triangle DEF are equal to the 3 angles in triangle GHJ for all 2 properties, okay, in this case and in this case. So in one, even though you don't have angle mentioned in the property, this is going to give you 3 angles in one triangle equal to the 3 angles in another triangle. So remember, the corresponding sides are in proportion for similarity. Okay, now let's solve a problem. Okay, so this is the question. You are given AD and BC intersect at E. AD and BC intersect at E. you are given angle A2 and angle C2 equal to x. Okay, angle A2 and angle C2 equal to x, and you are given AE is equal to 2 centimeters, AE 2 centimeters, BE 4 centimeters, okay, BE 4 centimeters, EC 8 centimeters, EC 8 centimeters, CD 12 centimeters. Now question 1. Prove that triangle AEB is similar to triangle CED. So we have to work in these two triangles. Okay, so in triangle AEB and CED, we are going to work in these two triangles. Okay, so let me show you the two triangles. Okay, so the first one is AEB. AEB. Okay, so AEB, AEB, and triangle CED, CED. Okay, CED. Okay, CED, CED. So these are the two triangles in which we are going to work. So we are going to use the property angle, angle, angle. For similarity, we have to prove that 3 angles in one triangle are equal to the 3 angles in another triangle. You can see you have angle A2 is equal to angle C2 in another triangle because they are all equal to x. Okay, so this is given. You have to write the reason. This is given. Angle E1 is equal to angle E3. Vertically opposite angles. Okay, vertically opposite angles are equal. Okay, now we have proved. Let me show you. This angle and this angle, and we have proved this angle and this angle. Now automatically the remaining angle, this and this angle, are going to be equal. If you can prove 2 pairs, automatically the third pair of angles, the angles are going to be equal. Okay, so angle B1 is equal to angle D2. The reason is sum of angles in a triangle. Okay, you can see if you have to prove. Can you see you have the chord AC? This chord is subtending angle B1 and angle D2. You can give your reason like this, or you can say angles in the same segment. Now we have these angles from one triangle and these angles from another triangle. Okay, can you see A2 is there, E1 is there, B1 is there. Okay, from one triangle, and you have these 3 angles from another triangle. Okay, you have C2, E3, and D2. Okay, so now you can conclude, therefore, triangle AEB is similar to triangle CED. The reason why you are saying this triangle is similar to this triangle is you used the property angle, 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 or you can write like this, okay? Angle, angle, angle. Always make sure whenever you are writing that this triangle is similar to this triangle, make sure this angle, the angle at A in this triangle, is equal to the angle at C in this triangle. Okay, you can see the angle A2 is equal to the angle C2. Okay, angle at A is equal to the angle at C, and angle E1 is equal to the angle E3. Okay, you have E and E. Angle B, the third letter in this triangle, is equal to angle D, the third letter in this triangle. Okay, can you see? Angle B1 is equal to angle D2. Okay, so now question 2. Determine with reasons the lengths of AB and DE. Okay, we can still use the same triangles, triangle AEB and CED, because you need AB. There is AB in this triangle. Okay, there is AB, and you need DE. There is DE. You have it in this triangle. So we are going to work with these triangles because we have AB, okay, AB and ED or DE. So we're still going to use these two triangles. Okay, so after proving that the two triangles are similar, you can write the proportionality equation, and then you are going to solve for AB and DE. Okay, let's write the proportionality equation. So you have the first letter and the second letter in this triangle over the first letter and the second letter in another triangle, okay, over CE, equal to, now, the first letter and the third letter over the first letter and the third letter in another triangle. Okay, so AB over CE. This is equal to, now you have second and third letter over second and third letter in another triangle. So this is equal to EB over ED. The reason why you can write the proportionality equation, you have to say this triangle is similar to this triangle. You can only write the proportionality equation if you have one triangle similar to another triangle. Or the reason can be, you can say similar triangles. Or the reason can be, you can say corresponding sides in proportion. Remember, similar triangles have got sides in proportion. Okay? This reason is used most of the time. Okay? So now we can solve for AB. Okay? We can solve for AB because we have AB and we can solve for DE. We have DE or ED. Okay, DE or ED. Okay, so let's plug what we have. We have AE is 2 over CE. CE is 8. This is equal to AB. Okay, we are going to solve for AB over CD. CD is 12. Okay, from this you can solve for AB. Okay, you can solve for AB. You do cross multiplication. Okay, this is equal to EB. EB is 4 over ED. To solve for AB, you can use this part because you have enough information, because you have one unknown. Okay, let's solve for AB. You do cross multiplication. 8 times AB. This is equal to 2 times 12, 24. So AB is equal to 3 centimeters. You divide by 8 on both sides. Now, to find ED, you can use this part and this part. Since you have enough information, you can use this part and this part. You do cross multiplication. Okay, you have one unknown. Okay, so cross multiplication, 2 times ED equal to 8 times 4, which is 32. Now ED is equal to 16 centimeters. Now question 3, determine AC over BD. Okay, AC and BD. You can see we have to use other triangles. So let me do this. We need AC. Okay, AC. We need, let me do this. We need AC. Okay, AC. And we need BD. BD. Okay, BD. So can you see we can work in a triangle AEC. Okay, AEC and triangle BED. Since we have AC in this triangle and BD in this triangle, so in a triangle AEC and triangle BED, we are going to use these two triangles. Okay, so we are going to use these two triangles. Okay, okay, we can use similarity. We have to prove that the 3 angles in one triangle are equal to the 3 angles in another triangle. Okay, and then from there we are going to write the proportionality equation and try to solve for AC over BD. The arc CD or the chord CD is subtending equal angles at the circumference. Okay, so A1 is equal to B2. Write the reason. The reason is angles in the same segment. Please check lesson 14 of 25. Okay, angle E4 is equal to angle E2 in another triangle. The reason is these are vertically opposite angles. Okay, vertically opposite angles. Okay, E4 is equal to E2, vertically opposite angles. Okay, so after proving that two angles in one triangle are equal to two angles in another triangle, automatically the third angle in one triangle is equal to the third angle in another triangle. Okay, so let me show you. We have proved A1 is equal to B2. Okay, A1 is equal to B2 and E4 is equal to E2. Now we are left with, in this triangle, we are left with C1. In this triangle, we are left with D1. Okay, so automatically C1 is equal to D1 in another triangle. Okay, so these three angles are from one triangle, AEC. Okay, you have A1, E4, and C1. And these three angles are from another triangle. Okay, so the reason why the third angle in one triangle is equal to the third angle in another triangle, the reason is sum of angles in a triangle automatically. Okay, or you can prove if you want. Okay, let me show you. So you have C1 is subtended by AB and D1 is also subtended by chord AB. So the reason can be this. Okay, sum of angles in a triangle or angles in the same segment. So after this, you can conclude triangle AEC is similar to triangle BED. Okay, the reason why you can say this triangle is similar to this triangle, the reason is angle, 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 or you can write like this. Okay, because this is in the correct order, you can now write the proportionality equation. So you have AE over BE. Okay, first and second in this triangle over first and second in another triangle. This is equal to first and third in this triangle over first and third again in another triangle. Okay, BD. This is equal to now second and third. Okay, EC over second and third in another triangle. So you can use this part. Okay, so the reason why you can write the proportionality equation is because this triangle is similar to this triangle. This is why you can write the proportionality equation. Okay, you have to give the reason, or the reason can be given like this. Okay, similar triangles, or you can say corresponding sides in proportion. This property is used most of the time. Okay, you can use this property. So AC over BD is equal to AE is 2 over BE, which is 4. Okay, 2 over 4. This is equal to 1 over 2. Okay,